Hello everybody. Today we're going to talk about what's called the converse of the Pythagorean theorem. So let's start by going over your investigation that you should have already completed. And this is just to summarize the investigation. So you may recall the SSS triangle congruence shortcut that says if three sides of one triangle are congruent to three sides of another triangle, then the triangle is congruent. However, if you are given three side measures, that does not guarantee they will form a triangle. What does the triangle inequality theorem say about that? So, you should recall that the two smallest sides must add up to be greater than the third, the largest side. Right? And they cannot be equal. So if you had one long side and then two short sides, the two shorter sides had to be greater than the third side to even form a triangle. So that's really important. Now we're going to go even further today, and we're going to be able to classify the triangle. So the Pythagorean theorem is stated as, if a triangle is a right triangle and A and B are legs and C is the hypotenuse, then A squared plus B squared equals C squared. Write the converse below. So the converse is when you exchange the if and then statements. So if, and we're going to change it slightly, we're going to say if A and B are the two shortest sides of a triangle, and C is the longest, then, and, how do I erase this here? And A squared plus B squared equals C squared, then the triangle is a right triangle. Okay? And then you should have already explored the GeoGebra. And let's open that up to see. Oops, where did I put it? Here it is. So here you would see, if you move this, and then you move it back to a point where A squared plus B squared equals C squared, you would then see that it forces it to be a right triangle. And you can do that right through like this. Okay? Then we're going to look at, well, what if A squared plus B squared is less than C squared? So let's move it to a point where that is true. Okay. So down below, you could see that at this point, A squared plus B squared is less than C squared. Oh, look, the angle. What do you notice about the angle for all of these cases where it's less than? Oh, it's obtuse. Okay. Now what about if we make A squared plus B squared greater than C squared? It's an acute angle. Always keep side C as the longest side for this to happen. So side C has to be the longest side, and you will see that if A squared plus B squared is greater, like it is right now, then it's an acute angle, and if it's less than, it's an obtuse angle. Whoops, I hit the wrong one. Here we go. So, so let's fill in the blanks. If a squared plus b squared equals c squared, then the triangle is right. If a squared plus b squared is greater than c squared, the triangle is acute. And if a squared plus b squared is less than c squared, the triangle is obtuse. Now, there are certain cases where 5c does not work. And this goes back to question number 1 on this sheet. Okay. Isn't it possible for a squared plus b squared to be less than c squared, but a plus b is less than c? The two shortest sides could be smaller than the third side. So if a squared plus b squared is less than c, then it does not form a triangle. So you should actually test this first. So some examples would look like this. Classify the triangle as acute, obtuse, or right, or no triangle. So if you have, let's say, the sides 4, 5, and 6, keeping in mind the largest side will always be C, well, you're going to test 4 squared plus 5 squared. How does that compare to 6 squared? Well, before you do that, you should have checked that the two smallest sides added together, 4 plus 5 equals 9. It forms a triangle. You have to check that first. Now let's do the Pythagorean test. 16 plus 25 is 41. 41 is bigger than 36. Therefore, it is an acute triangle. Right? It'll always form the same triangle because of side, 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 and it will always be an acute triangle. It'll also be a scalene triangle because all three sides are different lengths. How about 3, 3, 5? So it's isosceles, but let's see. Let's check the two smallest sides. 3 plus 3 is 6. It forms a triangle. Now we can go on. 3 squared plus 3 squared. How does that compare to 5 squared? 9 plus 9 is 18. 18 is less than 25. So this will be an obtuse isosceles triangle. Now what if we had 2, 3, 5? 2 plus 3 equals 5, not a triangle. So if you went on to the test for the Pythagorean, it would come out to obtuse, but it actually will never form a triangle. And then we'll finish with 3, 4, 5. So then 3 plus 4 is 7. That forms a triangle. But 3 squared plus 4 squared is 9 plus 16 is equal to 5 squared, which is 25. That will be a right triangle. Okay, so that concludes our lesson. So please complete your assignment on Delta Math. Or is this one on Quizzes? Complete your assignment for today and have a wonderful day.